5, 4, 3, 2, 1. Welcome to Radioflash, Armada's dedicated electromagnetic defense and security podcast, with your host Tom Withington at the controls. Artificial intelligence and machine learning are two much-heralded technologies mooted to revolutionise SIGINT collection, processing and dissemination. An increasingly congested radio spectrum is set to challenge the limits of human cognition in the search for the signal of interest. But what precisely are these technologies? What do they bring to the SIGINT discipline? Are we in danger of seeing artificial intelligence and machine learning as a panacea that may ultimately be an anticlimax? With me today to discuss these questions and more is Patrick Krown Killingsworth, Director of Autonomy Projects at EpiSci. He joins us today from Colorado. Patrick, great to have you with us. Welcome to the podcast.
Thanks, Tom. It's a pleasure to be here.
So let's start off with some definitions. How would you define artificial intelligence and machine learning, and how do you differentiate these from one another?
That is a great question. So the short answer is that machine learning is a discipline inside a much bigger field of artificial intelligence. And it's a good question because it's generally used interchangeably by a lot of the public, and to include me, to sort of act as, you talk about AI or ML as technology working for you to help augment human cognitive workload or to help take tasks away from your own, personal execution. So inside of artificial intelligence, there's really a wide number of fields, and some of those are really doing, or I say the entire field of artificial intelligence is doing anything with a machine that has some sort of logic to it. So it's not just simple automation or repeating a process, but is actually performing a task that involves, sometimes just a small amount of thinking. So that could be sorting objects, or it could be on the far extreme side, these incredibly powerful tools like ChatGPT. And a lot of the ways that the machines learn to do a task is we explicitly tell them. We give them rules. We say, if you see this, do this. If you see something else, I want you to do something else. And that is one way you can have these machines accomplish these fairly logical things, and that is inside of artificial intelligence. Machine learning is a subset of that where you don't have those explicit rules. So I have not directly told a machine, this is how I want you to accomplish the task. I've told it what the task is, and I have trained it to optimize its own way to accomplish the task. And so one of the attributes of that is that usually when you talk about machine learning, there is an incredible amount of data involved in that training. But it's fairly analogous to the way that we learn to perform tasks as humans. We see a task, we experience it a number of times, and then we get better at it. And it's the same with machine learning, but it's very, very data intensive. Instead of seeing a task a few dozens or 100 times, it may be thousands or millions of exposures to this task in order to really have the optimal solution to it.
What do you feel these technologies can contribute to SIGINT as a discipline?
Yeah, so I guess I would start with defining what I think signals intelligence is, which when you talk about intelligence, I think of, we collect a signal and then we want to analyze it to figure out where is it coming from, what is making it, and what is really the purpose of this signal. So I think artificial intelligence and really machine learning as a specific discipline inside of that has a couple of really unique capabilities. And one is that because it is trained on these vast amounts of data, these ML algorithms are really good at processing huge amounts of data, more than a human can. So it's really augmenting the human's capacity to perform the analysis, where one individual could only look at so many things in a given set of time. With the ML algorithms helping them out, now you can do 10, 20, 100 times more analysis. And when you've got more data than you can physically process, that is incredibly helpful. The other piece of that is, because the training has taken place over these very, very large data sets, sometimes the accuracies can exceed even what we can do as a human, just because they have so much experience. You can get some very, very precise solutions. So it's not replacing the human, it is really just augmenting them, giving them an extra tool to perform a lot more data analysis, and in a lot of cases, even more accurately. But ideally, it is sifting through the vast amounts of data and then finding the really interesting bits to flag for, now let's get some human intervention and some human eyes onto this particular signal.
What are the potential risks of using artificial intelligence and machine learning to help SIGINT, and how can these risks be mitigated?
I think before I start with the risk, I might actually start with the challenge. And one of the challenges is that because they are trained on these vast amounts of data, you have to have vast amounts of data in order to train them. And just by definition, with signals intelligence, it may be hard to get those signals or enough variations and flavors of it to really train these algorithms. And so a lot of what we wind up doing, especially for the initial training or the pre-training, is using synthetically generated data. And this isn't unique to signals processing. They do this in the computer vision world as well, where you build a 3D model of something and then you create a bunch of CGI images of it and you use that to train your computer vision. We do the same thing with signals. And that brings up one of the first risks, and that's, if you train something purely on synthetic data, the risk is that it doesn't work in the real world. I've seen a lot of systems that work exquisitely on these, in simulation, but don't actually field well. And, the first way you mitigate that is by really designing that capability, that robustness in from the start. So you have to plan for real world employment. It's a problem we see in our embodied autonomous systems. We call it like the sim to real problem. How do I make something go from simulation to real? That also applies in the signal space. My signals engineers call it generalization. It has to be general enough that it works out in the real world. So that's really the first risk. In a way, we attack that problem is by designing it in from the start. You'll also hear about what happens when someone finds a way to break or to trick or to exploit that algorithm. That's that adversarial AI, adversarial ML that you read about. So what that is someone has found a way, but they have figured out, or maybe they don't even explicitly know, they just see that something works. They have figured out what attributes the system uses to classify certain signals, and then they've been able to take advantage of that to trick the system. There's a couple of fairly funny cases, again, more in the computer vision world, but it's just easier to kind of conceptualize. There was a system that was supposed to do like perimeter detection to detect people sneaking up on it, like for a base defense. And so they fielded it, and of course they let a bunch of US Marines kind of experiment and figure out how to sneak up on this. And there's the traditional approaches you would think of, someone in a ghillie suit kind of sneaking up. But then other Marines figured out, if I just hold a branch in front of my face and walk like a tree up to it, or someone else put a cardboard box on their head and wrote, "I'm a tree," and it broke the algorithm, right? So, but in the signals world, these can be much more nuanced attacks. And so it's going to happen. The key is that you have to be able to quickly retrain your algorithm and then push that back out into the field. And so, there's a technical approach in that, we have to be able to recognize it, to be able to retrain, and then to be able to update the systems. But there's also, a bigger acquisition approach to that the institutions that use these have to be flexible enough that we're not just designing one exquisite system and throwing it over the fence to the operator. It is an iterative process where we want to really be engaged with the users, updating it to keep things relevant to their needs, and keeping that cycle going.
How do you expect to see these technologies being exploited in the future to help SIGINT?
The obvious answer to that in the signals intelligence field is that these systems keep getting smarter, they keep getting faster, and they just keep getting more accurate. And so that continues there. I think something that we are really interested in is taking all of that technology and then moving it from the strategic intelligence operations center level down to the tactical edge. And we think there's a lot of capability at kind of the operationally deployed system level to a lot of opportunity to take advantage of these techniques as well. Right now, most of those operational systems, or I should say a lot of them, because they have to be lightweight, they have processing limitations, power limitations. They rely on some fairly simple techniques, and most of that's just a lookup table. I load a mission data file into these tactical systems. It's a library of things I've seen in the past that all of our signals analysis has generated, right? And then when I receive a signal, I break it down into a bunch of attributes and I just compare it against that lookup table. And if it matches close enough, I flag it as this is the thing that I'm interested in and might be relevant to me. There's a risk in that when the signals change, if they change enough, you don't recognize them. So where we see our AI and our ML algorithms helping out is that now we can deal with that change in a little bit more of an intelligent way. And so these edge systems, these operational systems have a lot more capability. There's another good analogy to the music world, right? It's still signals processing, just in a slightly different frequency domain. If you remember your first cell phone mine back in the 2008, 2009 timeframe, there was the Shazam app that I thought was magic at the time, where you record 10 seconds of data and it goes and looks at a lookup table. If it matches exactly, I get the artist, I get the album, I get the track, which is, I'm getting similar information about signals, right? When I do that in that domain. But back then, if you went and recorded the artist singing their song live, it wouldn't work, right? Because there were just too many variations in the real world with their real voice and the real environment. And now that technology has progressed to where, you can listen to a live song. You can even listen to an acoustic version of a song that will still most of the time figure it out. So we see that as where we are going, especially on the tactical edge with these systems, where it doesn't have to match exactly, and it might even be a completely new signal. It could be a new song, but I have enough experience listening to these signals that I still know what it's trying to do, what it's trying to accomplish. I might even be able to guess where it came from, even if I haven't done the work in the past to exactly have that in my library.
Patrick, thanks very much for clearing up a lot of the questions that I've had, and I think a lot of our listeners will have had about those exact definitions of artificial intelligence and machine learning, how they differentiate from each other, and also the very important questions of how they are already influencing signals intelligence collection, processing, dissemination, for example, the effect they're going to have in the future. Do please come back and talk to us again in the future. Let us know how it's going, other cool things that you and your colleagues are doing in this area. But for now, thank you very much for joining us.
Thanks, Tom, for having me. I had a good time.
If you'd like to learn more about EpiSci and their work, please visit their website at episci.com. And don't forget, there's more defense security, electromagnetic news and analysis at armadainternational.com. That's all we have time for. Thanks very much for listening.